Astronomers say that one of the rarest comets ever observed, the mysterious 3I/Atlas, likely isn't traveling through the vastness of space alone, and that more strange interstellar visitors may already be silently approaching our solar system, waiting to be detected by the new generation of powerful observatories now scanning the sky. Although 3I/Atlas is only the third confirmed interstellar object ever detected in our planetary neighborhood, scientists believe that such discoveries will soon become far more common because of improved detection technology that allows astronomers to observe fainter, faster, and more distant objects than was previously possible. The unusual comet, currently embarking on a long journey that carries it deeper into our solar system, will pass by the planet Mars next month before eventually making its closest approach to Earth. However, from our vantage point, its moment of closest arrival will ironically be hidden from view, as the comet will slip behind the Sun and become obscured by its glare, preventing astronomers from capturing the kind of detailed close-up observations they would have hoped for. While this temporary invisibility is disappointing, it does not diminish the excitement in the scientific community, because researchers feel confident that the future holds many more chances to study similar objects, especially as new facilities come online. Indeed, the unexpected arrival of 3I/Atlas has already strengthened the belief that interstellar objects, once thought to be extraordinary and exceptionally rare, may actually be far more abundant than earlier generations of astronomers realized, simply passing undetected, because sensitive instruments capable of spotting them did not yet exist. As the years ahead unfold, astronomers are almost certain that additional opportunities will arise to observe strange visitors from beyond our solar system, presenting an entirely new frontier for scientific exploration and potentially answering long-standing questions about the origins of planetary systems, the composition of distant cosmic regions, and even the conditions under which planets, comets, and small bodies form in the earliest stages of stellar evolution. According to Astronomy, a PhD student and Fannie and John Hertz Foundation Fellow at the University of Michigan, such discoveries are expected to increase dramatically once the Rubin Observatory's legacy survey of space and time begins full operation. Taylor explained in an email to the debrief that the Rubin Observatory's decade-long survey period is likely to reveal a steady stream of interstellar objects crossing into our region of space, giving astronomers unprecedented opportunities to study material originating from other star systems. The prospect of multiple interstellar detections over 10 years is thrilling for scientists, because up to now only 2 such objects had been clearly identified in history before 3I/Atlas. The cigar-shaped interstellar traveler known as Oumuamua, discovered in 2017, and Comet 2I/Borisov, found in 2019. The addition of 3I/Atlas to this small catalog marks only the beginning of what many researchers anticipate will become a rapidly growing list as technology continues to improve. The Rubin Observatory is considered special in the search for interstellar objects because its advanced design enables it to scan the entire southern sky repeatedly with extraordinary sensitivity, capturing vast amounts of data far faster than any previous observatory. Located in Chile, the facility uses an enormous 8.4-meter telescope paired with the world's largest digital camera ever built for astronomy, allowing it to detect faint moving objects at incredible distances and across enormous sections of the sky. Even during its early commissioning phase, before full scientific operations had officially begun, the observatory demonstrated remarkable performance. Within only a few hours of testing, it succeeded in detecting more than 2,100 previously unknown asteroids, offering an impressive preview of the groundbreaking discoveries likely to emerge once continuous surveys begin. The observatory's powerful detection capabilities extend not only to asteroids within our solar system, but also to any unusual interstellar bodies drifting through space at high speeds and unusual trajectories, making it an essential tool in the future of cosmic discovery. In fact, during this very commissioning period, the observatory managed to capture images of 3I/Atlas several days before its official identification, although the interstellar comet went unnoticed in the data until after NASA had already confirmed its discovery. This demonstrates how the Rubin Observatory's enormous data output will require advanced computational analysis and automated detection tools, because the volume of information it collects is so large that intriguing objects may initially be missed within the flood of images. The fact that 3I/Atlas was unknowingly photographed before its official discovery suggests that the skies are likely filled with many more interstellar wanderers that will soon be identified as new systems of detection algorithms, artificial intelligence, and automated sky scanning routines grow more sophisticated. Researchers believe that the observatory's legacy survey of space and time, which will operate for 10 full years, will fundamentally transform our understanding of how often interstellar objects enter our solar system. Instead of rare lone visitors, these objects might turn out to be relatively common messengers from distant corners of the galaxy, each carrying with it physical clues about the environments in which other stars and planets were born. Every new detection offers a unique opportunity to study fragments of material that formed around stars far beyond our Sun, possibly billions of years ago, and which have been drifting through interstellar space ever since. By analyzing their composition, their trajectories, their shapes, and their chemical signatures, astronomers can gather unparalleled insights into the processes that shape distant planetary systems, insights that would be impossible to obtain using telescopes alone. Although 3I/Atlas will soon disappear behind the Sun from Earth's perspective, its brief appearance has already fueled intense interest because the data gathered so far suggest it is unlike anything previously observed. Scientists hope to continue analyzing its motion and brightness even while it is out of view, using indirect methods to study its behavior as it travels deeper through the solar system. Once it emerges again, telescopes around the world will likely attempt to gather whatever additional information they can before the interstellar object accelerates back into the dark reaches of space. More importantly, however, astronomers know that this will not be the last opportunity to study such a phenomenon. Instead, it represents one step in what is expected to be a rapidly expanding field of interstellar object research. The possibility that 3I/Atlas might not be alone, and that numerous similar objects could be entering our solar system on a regular basis, has transformed scientific expectations about how dynamic and interconnected our region of space may truly be. For decades, astronomers believed that encounters with objects from beyond our solar system would be exceedingly rare, perhaps occurring once every several centuries or even millennia. But the discoveries of Oumuamua, 2I/Borisov, and now 3I/Atlas have overturned this assumption, suggesting instead that such interstellar travelers may pass near the Sun far more often than anyone previously imagined. The only reason they were not seen earlier was that technology lacked the sensitivity to detect them. With the Rubin Observatory and other next-generation telescopes coming online, that era of invisibility is ending, and humanity is entering a new phase of cosmic awareness in which the boundaries between star systems seem less isolated than once thought. In the coming decades, as large sky surveys generate enormous amounts of data, scientists will likely discover a wide diversity of interstellar visitors, icy comets, rocky fragments, possibly even dead remnants of distant planets or the shattered debris of ancient worlds. Each object will add a new piece to the puzzle of how matter moves through the galaxy and how different star systems exchange material over cosmic timescales. The excitement surrounding the Rubin Observatory stems from its ability to capture these fleeting travelers before they vanish again into interstellar space, giving scientists precious opportunities to study the chemistry, physics, and origins of material that formed under conditions entirely different from those in our own solar system. The era ahead promises not just more discoveries, but deeper understanding, as every new interstellar object pushes the boundaries of human knowledge and brings us closer to grasping the vast, interconnected nature of our galaxy.